Now, we shall arrive at an expression for electric intensity on the equator of an electric dipole. Equator. So, ಈಗ equator ಅಂದ್ರೆ ಏನು ಅಂತ ಆಗಲೇ ಗೊತ್ತಿದೆ. If you have an electric dipole, and if the length of the dipole is bisected perpendicularly, then the perpendicular bisector will be called as dipole equator. That's what you have understood from the previous classes. So we will find electric intensity at some point on the equator of the dipole. So point L delta at whatever the distance from the center of the dipole, we will arrive at an expression for the intensity. So before going to that, so you first use vector concept ಏನು ಕಲ್ತಿದ್ವಿ ಅದನ್ನು ಒಂದ್ಸರಿ ನೋಡ್ಕೊಳ್ಬೇಕು. Now let me say you have some point O and there is a vector of magnitude A which is directed as shown in the diagram, whose initial point is at O. So now if you can draw two mutual perpendicular lines intersecting at the initial point of vector A. Vector A O ಇಂದ ಶುರುವಾಗ್ತದೆ. ನಾನು ಮ್ಯೂಚುವಲ್ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಲೈನ್ಸ್ ಹಾಕೊಂಡಿದ್ದೀನಿ. ಅವೆರಡೂ ಮ್ಯೂಚುವಲ್ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಲೈನ್ಸ್ O ನಲ್ಲಿ ಇಂಟರ್ಸೆಕ್ಟ್ ಆಗ್ತದೆ. Let us say this A vector is at an angle theta to one of the lines, say horizontal line here in this case. Now I can resolve this vector A, resolve vector A into two components, one along the horizontal, that is A cos theta, the other along the vertical, that is A sin theta. This A sin theta and A cos theta are called the orthogonal components, perpendicular components of vector A. Artha ಏನು? Vector A, supposing imagine that vector A is a force. So vector A ಏನು ಕೆಲಸ ಮಾಡುತ್ತೋ ಅಥವಾ ಏನು ಪರಿಣಾಮವನ್ನು ಉಂಟು ಮಾಡುತ್ತೋ, ನಾನು ವೆಕ್ಟರ್ A ನ ತೆಗೆದುಬಿಟ್ಟು ಇವೆರಡು ವೆಕ್ಟರ್ಸ್ ಹಾಕಿದೆ. ವೆಕ್ಟರ್ A sin cos theta and vector A sin theta, where theta is the angle between vector A and the horizontal component. Then vector A ಏನು ಪರಿಣಾಮ ಮಾಡ್ತಾ ಇತ್ತು, ಇವೆರಡು ಅದೇ ಪರಿಣಾಮವನ್ನು ಉಂಟು ಮಾಡುತ್ತೆ. So that is called resolution of vectors. So ನಿಮಗೆ ಇದು ಕೊಸೈನ್ ಕಾಂಪೋನೆಂಟು ಅಂತ ಅನ್ಕೋಬಾರ್ದು. ಯಾವಾಗಲೂ ಕೊಸೈನ್ ಕಾಂಪೋನೆಂಟ್ ಮಲಗಿರುತ್ತೆ, ಸೈನ್ ಕಾಂಪೋನೆಂಟ್ ನೀತಿರುತ್ತೆ ಅಲ್ಲ. ನಮಗೆ ಕೊಸೈನ್ ಫಂಕ್ಷನ್ ಡೆಫಿನೇಷನ್ ಏನು? ಅಡ್ಜಸೆಂಟ್ ಸೈಡ್ ಆಫ್ ದ adjacent side to the given angle to the hypotenuse in the right angle triangle. If theta is adjacent ಆಯಿತು, ಅದಕ್ಕೆ ಇದು cosine component ಆಯಿತು, ಇದು sin component. Supposing if you take this angle as theta, and adjacent side ಯಾವ್ದಾಯಿತು ಇದೆ, adjacent to angle theta ಇದಾಯಿತು. ನಾವು ಏನಾಯಿತು, ಇದು cosine component ಆಯಿತು, ಇದು sin component. So means to say, you can express a vector as resolved components of two vectors. One has a sine component, the other has a cosine component. ಇದಕ್ಕೆ ರೆಸಲ್ಯೂಷನ್ ಆಫ್ ವೆಕ್ಟರ್ಸ್ ಅಂತ ಕರೀತಾರೆ. ಇದು ಪ್ರೀವಿಯಸ್ ನಾಲೆಡ್ಜ್. ನಿಮಗೆ ಈ ನಾಲೆಡ್ಜ್ ಮೊದಲೇ ಇತ್ತು, ಸುಮ್ಮನೆ ಒಂದ್ಸರಿ ನೆನೆಸಿರ್ತೀನಿ. ಯಾಕೆಂತಂದ್ರೆ ಈ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಡಿರೈವ್ ಮಾಡಬೇಕಾದ್ರೆ ನಮ್ಗೆ ಅದು ಬೇಕಾಗುತ್ತೆ. Now here, let me consider a dipole X. On dipole ತಗೊಳ್ತೀವಿ. So ends of a dipole will be called as A and B, and as usual 2A is the dipole length. So A and B are the ends of an electric dipole. Electric ಅಂತ ಬರೆದು ನಡೆಯುತ್ತೆ, ಬರೆಯೋದು ನಡೆಯುತ್ತೆ. ಅದು ಎಲೆಕ್ಟ್ರಿಕ್ ಅಂತ ಯಾಕೆ ಬರೀತೀವಿ ಅಂತಂದ್ರೆ ಮ್ಯಾಗ್ನೆಟಿಸಮ್ ಅನ್ನು ಡೈಪೋಲ್ ಇರುತ್ತೆ, ಅದಕ್ಕೆ ಎಲೆಕ್ಟ್ರಿಕ್ ಅಂತ ಮೆನ್ಷನ್ ಮಾಡಬಹುದು. A and B are ends of an electric dipole. Right. 2A is its length. Oh, fine. Now O is its center, and you have a perpendicular bisector, and you all know that this perpendicular bisector will be called as the equator of the dipole. So equator ಮೇಲೆ at some distance x from the center of the dipole, I assume a point C. So I write here C is a point at distance x from the center of the dipole on its equator. Now I will join these two. Naturally, the 2A ಆದ್ಮೇಲೆ OA will be A, OB will also be. So ಈಗ ಇದು ರೈಟ್ ಆಂಗಲ್ ಟ್ರಯಾಂಗಲ್, ಯಾಕಂದ್ರೆ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಬೈಸೆಕ್ಟರ್. ಇದು x ಇದು A ಆದ್ಮೇಲೆ BC and AC. Pythagoras theorem happens both are of length root of x square plus a square. Naturally, Pythagoras theorem. So, ಇಲ್ಲಿ by Pythagoras theorem ಅಂತ ಏನು ಬರೆಯೋದು ಬೇಡ. Therefore, BC and AC are both of length square root of x square plus a square. So, this are basics, preliminaries. Now, my intention is to find electric intensity on the equator. Electric intensity on the, as told many a times, it's the force on a unit positive charge. So now in 1 coulomb charge assume ಮಾಡ್ಕೊಳ್ತೀನಿ. So what happens when 1 coulomb charge is placed at that point? So 1 coulomb charge on a point ಅಲ್ಲಿ place ಮಾಡಿದ್ರೆ charge at A will repel the charge at C. So it will repel the charge at C like this. So intensity E1 ಅಂತ ಬರ್ಕೊಳ್ತೀವಿ. Like charges B, which is the charge which contains charge minus Q, will attract the charge at C. I will call it as V2. So now directions mark ಮಾಡಿಬಿಟ್ಟಿದ್ದೀನಿ. Now I will write here electric intensity at C due to charge at A ಅಂತ ಬರೋದು. E1 ಅಂತ ಬರೆಯೋಣ. This is 1 by 4 pi epsilon naught charge at A by AC square. ನಾನು ಸಿ ಅಂಡ್ ಎ ಪಾಯಿಂಟ್ಸ್ ತಗೊಂಡು ಎ ಸಿ ಸ್ಕ್ವೇರ್, ಸಿ ಎ ಸಿ ಎರಡು ರೂಟ್ ಆಫ್ ಎಕ್ಸ್ ಸ್ಕ್ವೇರ್ ಪ್ಲಸ್ ಎ ಸ್ಕ್ವೇರ್, ರೂಟ್ ಆಫ್ ಎಕ್ಸ್ ಸ್ಕ್ವೇರ್ ಪ್ಲಸ್ ಎ ಸ್ಕ್ವೇರ್ ಸ್ಕ್ವೇರ್ ಮಾಡಿದ್ರೆ ಎಕ್ಸ್ ಸ್ಕ್ವೇರ್ ಪ್ಲಸ್ ಎ ಸ್ಕ್ವೇರ್. ಸೊ ಇಲ್ಲಿ ಒಂದು ಯೂನಿಟ್ ವೆಕ್ಟರ್ ಬಂದ್ಬಿಡ್ತೀನಿ, ಇದು ವೆಕ್ಟರ್ along the vector ನೋಡಿ ರಿಪೀಟ್ ಆಗ್ತದೆ ಎ ಸಿ ಅಂತ ಬರುತ್ತೆ, ಎ ಇಂದ ಸಿ ಕಡೆ. ಸೊ ದಿಸ್ ಇಸ್ ಸಿಮಿಲರ್. ಸೊ ಎಲೆಕ್ಟ್ರಿಕ್ ಇಂಟೆನ್ಸಿಟಿ at C due to the charge at B naliro charge. What happens? I call it T2. I write it like this: 1 by 4 pi epsilon naught Q. Same number. You less magnitude, you less to magnitude. Right? This is also remains same. So ಹಾಗಾಗಿ x square plus a square ಬರುತ್ತೆ. ಆದರೆ the direction of E2 is along the vector C. So adike namige n cap is equal to the direction of E2. Here n cap is equal to the direction of E1. So along the vector, so C B and B. Okay. Now at point C, I will draw a line parallel to A. So one line assume ಮಾಡ್ಕೊಂಡಿದ್ದೀನಿ from point C parallel to the line A. So here we will draw a line parallel to the line BC. Sorry. AB passing through points point C. Let me assume this angle as alpha. ಈ angle alpha ಅನ್ಕೊಳ್ತೀನಿ. ಇದು ಐಸೋಸೆಲಸ್ ಟ್ರಯಾಂಗಲ್, ಇದೂ ಆಲ್ಫಾ ಆಗುತ್ತೆ. ಇದು ಆಲ್ಫಾ ಆದರೆ ಈ ಆಂಗಲ್ ಆಲ್ಫಾ ಆಗುತ್ತೆ. ಇವೆರಡು ಕಂಪೇರ್ ಮಾಡಿದ್ರೆ ಇವೆರಡು ಆಲ್ಟರ್ನೇಟ್ ಆಂಗಲ್ಸ್, ಇವೆರಡು ಪ್ಯಾರಲಲ್ ಲೈನ್ಸ್ ಆಗಿದ್ದಕ್ಕೆ ನ್ಯಾಚುರಲಿ these two angles will be equal. ಇದು ಆಲ್ಫಾ ಆಗಿದ್ದಕ್ಕೆ ಇದು ಆಲ್ಫಾ ಆಗುತ್ತೆ. ಬಟ್ ಕರೆಸ್ಪಾಂಡಿಂಗ್ angles. So if let angle CBO equal to alpha. Okay, ಇದು ಆಲ್ಫಾ ಆಯಿತು, ಇದು ಆಲ್ಫಾ ಆಯಿತು. ಯಾಕೆಂದರೆ ಇವೆರಡು ಕರೆಸ್ಪಾಂಡಿಂಗ್ ಆಂಗಲ್ಸ್, ಇವೆರಡು ಆಲ್ಟರ್ನೇಟ್ ಆಂಗಲ್ಸ್. Now vector E1, this is alpha, is resolved as E1 cos alpha along the horizontal and E1 sin alpha along the vertical. Resolve ಅಂದ್ರೆ ಒಂದು ವೆಕ್ಟರ್ ಎರಡು ವೆಕ್ಟರ್ ಸ್ಪ್ಲಿಟ್ ಮಾಡಿ ಮ್ಯೂಚುವಲಿ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಡೈರೆಕ್ಷನ್. ಈ E2 ಅಷ್ಟೇ, ಹಾಗೆ ನಾನು ರಿಸಾಲ್ವ್ ಮಾಡ್ತೀನಿ. ಇದು E2 cos alpha ಆಗುತ್ತೆ, ಇದು ಈ ಕಡೆ ಡೈರೆಕ್ಟ್ ಆಗಿರುತ್ತೆ, ಇದು E2 sin alpha. Understood? Clearly, this E1 is resolved as E1 cos alpha along the horizontal, E2 sin alpha along the vertical. This E2 is also resolved as E2 cos alpha along the horizontal and E2 sin alpha along the vertical. So resolve the vectors E1 and E2 into sin cosine components as in the diagram. Sine and cosine components as in the diagram. Point ತೋರಿಸಿರೋ ಹಾಗೆ ನೀವು ರಿಸಾಲ್ವ್ ಮಾಡ್ತೀವಿ. You see here, E1 and E2 are equal in magnitude. E1 sin alpha, E2 sin alpha should also be equal in magnitude. E1 E2 equal ಆದರೆ ಈ angles equal ಆದರೆ E1 sin alpha, E2 sin alpha equal ಆದರೆ these E1 sin alpha and E2 sin alpha are acting at same point and they are directed mutually in opposite direction. ಎರಡು ವೆಕ್ಟರ್ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಈಕ್ವಲ್ ಇಟ್ಟು ಆಪೋಸಿಟ್ ಡೈರೆಕ್ಷನ್ ಇದ್ದರೆ ನ್ಯಾಚುರಲಿ ದೇ ಕ್ಯಾನ್ಸಲ್. ಯಾರೋ ಒಬ್ಬ ಒಂದು ಪಾಯಿಂಟ್ ಅಲ್ಲಿ 5 ನ್ಯೂಟನ್ ಫೋರ್ಸ್ ಹಾಕ್ತಾ ಇದ್ರೆ ಇನ್ನೊಬ್ಬ ಆಪೋಸಿಟ್ ಡೈರೆಕ್ಷನ್ 5 ನ್ಯೂಟನ್ ಫೋರ್ಸ್ ಹಾಕ್ತಾರೆ, ಈ ಪಾಯಿಂಟ್ ಈಕ್ವಲಿಬ್ರಿಯಂ ಅಲ್ಲಿ ಇರುತ್ತೆ, ರೆಸ್ಟ್ ಅಲ್ಲಿ ಇರುತ್ತೆ, ದಿ ಕ್ಯಾನ್ಸಲ್. Similarly, sine component of E1, sine component of E2 gets cancelled because they are mutually opposite. Okay, and then the sine components of vector E1 and vector E2 cancel each other. Find the cosine components adds up. So E1 sin cos alpha, E2 cos alpha, they are on the same direction, therefore they add up. But the cosine components add up. Or adds up. Clear? Therefore, the resultant intensity at C will be E into the E1 cos alpha plus E2 cos alpha. So here come on. Since E1 and E2 are equal, E1 E2 equal ಇರೋದಕ್ಕೆ I can write 2E1 cos alpha because E1 magnitude, E2 magnitude are equal along the same direction. So they are equal. Therefore, E1 cos alpha, E2 ಬನ್ನಿ ನಾವು E1 ಹಾಕೋದು, E1 cos alpha plus E1 cos alpha is 2E1 cos alpha. Again. Now I will substitute for E1, vector E1. So vector E1 and substitute for 2. E1 is here 1 by 4 pi epsilon naught q divided by x square plus a square. Here diagram ನೋಡೋಣ. Cos alpha in alpha ಇದು ಒಂದು right angle triangle. OBC is a right angle triangle. Say alpha. Cos alpha by definition it is a divided by root of x square plus a square. So a by root of x square plus a square. I will write here because in triangle OBC, triangle OBC, cos alpha is equal to a divided by root of x square plus a square. This is it. So, very well understood. So, you know the unit vector happen. The unit vector here doesn't happen. But, in 2a, in 2a, you all know q into 2a is vector p dipole moment. 2 into 2a is dipole moment. Therefore, so this E becomes Q into 2a is P. So in 1 by 4 pi epsilon. And now this is Q into 2 is P. It is x square plus a square, root of x square plus a square. ನೋಡಿ m ಮತ್ತು ರೂಟ್ m ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದ್ರೆ m ಪವರ್ 1 into m ಪವರ್ ಹಾಫ್. This is m power 1 plus half. Basis saving the power side. This is m power 3 by 2. Adhe concept ali naan employ madre. The same concept is employed here. So I get this as x square plus a square root of x square plus a square. X square plus a square whole power 3 by 2. So P vector, so this is the formula for electric intensity on the axis of an electric dipole. So it is very clear that the axis on the electric dipole is, electric intensity on the axis of the electric dipole is E is equal to 1 by 4 pi epsilon naught vector P by x square plus a square whole power 3 by 2, where A is the semi-dipole length, x is the distance of a point on the equator at this from the center of the dipole, P is the dipole moment, which is the product of the magnitude of one of the charge and the dipole length. So this derivation will be of great importance as far as the examination is concerned. So you need to practice it. So ondeರಡು ಮೂರು ಸಲ practice ಮಾಡಬೇಕು. ಕಷ್ಟ ಇಲ್ಲ, easy ಇರುತ್ತೆ. So this is how you find the expression for the electric intensity on the axis of the dipole and the equator of the dipole. Today, for a short dipole, ಈ ಕೇಸ್ ಶಾರ್ಟ್ ಡೈಪೋಲ್ ಅಂದ್ರೆ ಯಾವುದು ಅಂತ ನಾವು ಆಗಲೇ ಪ್ರೀವಿಯಸ್ ಕೇಸಲ್ಲಿ ನೋಡಿದ್ವಿ. ಸೆಮಿ ಡೈಪೋಲ್ ಅಂತ ಡಿಸ್ಟೆನ್ಸ್ ಆಫ್ ದ ಪಾಯಿಂಟ್ on the equator ಗಿಂತ ತುಂಬಾ ಕಡಿಮೆ, if it is very very small, then you call the dipole as a short dipole. And you all know, in such a case, A can be neglect ಮಾಡಿ. So ಈಗ neglecting A in the equation E is equal to 1 by 4 pi epsilon naught P divided by x square plus a square whole power 3 by 2. Neglecting A, you can write E is equal to 1 by 4 pi epsilon naught P divided by x square whole power 3 by 2. Since A is neglected, A bittirodike ishtirodu. So E becomes 1 by 4 pi epsilon naught P by x square whole power 3 by 2 is x cube. So this is the electric intensity on the equator of a dipole due to a short dipole. So short dipole is the form. So ನಮಗೆ axis ತಗೊಂಡಾಗ into ಬಂದಿತ್ತು. So E on the axis. So intensity on the axis. Axis of short dipole. Short dipole axis ಮೇಲೆ intensity E is equal to 1 by 4 pi epsilon naught 2p by x cube ಬಂದಿದೆ. ಇಲ್ಲಿ ನಾನು I will write it as E axis ಅಂತ. So for a short dipole, okay, intensity on the equator will be E equator is 1 by 4 pi epsilon naught T by x. Isn't it? So ratio ತಗೊಂಡ್ಬಿಡಿ ಎರಡನ್ನು. E axis east to E equator is equal to, ನೋಡಿ ಇಲ್ಲಿ 2 ಇದೆ, ಇದಿಲ್ಲ ಅಷ್ಟೇ. So 2 is 2. So this relation holds good only for a short dipole. Short dipole ಇದೆ ಅಂದ್ರೆ ಮಾತ್ರ ಈ relation. If it is not a short dipole, then you cannot say that this relation holds. So you practice all this, which are very important. So some of the questions will be asked in CET regarding this concept also. So practice well.